All right, next we're going to consider intercepts, the intercepts of graphs. We've kind of already spent a great deal of time with the y-intercept. The y-intercept is the place where the graph crosses the y-axis. It is a point of the form x is 0, y is b, point 0, b. And of course, this means that x at that point is 0. We also have an x-intercept that we can discuss. This will be the place where the graph crosses the x-axis. It's a point of the form a, 0. So x is some number a, and the value of y at that point is 0. As long as we have a line that is neither vertical nor horizontal, we will have both. We will have an x and a y-intercept. So if we want to find the x and the y-intercepts, we note that the x is the point a, 0. To find that, we set y equal to 0 and then solve for x. Similarly, y-intercept being the point 0, b, we can set x equal to 0 in our equation and then solve for y. Now, it may happen occasionally that we have a line that passes through the origin. The origin is the point 0, 0. If that happens, then this point is both the x and the y-intercept, and we're a little sad because that doesn't really help us if we want to graph the line. If our line does not pass through the origin, then we can use the x and the y-intercepts to graph the line, because that will give us 2 points on the line, and that's all we need in order to graph it. Let's give it a try. Let's use the x and the y-intercepts to graph the line y equals 2x plus 4. We'll start out by finding the x and the y-intercepts. Over here, I want to find the x-intercept. I'll have a little reminder here that this is the point where y equals 0. So I can take my equation, put in 0 in place of y. Now it's a matter of solving for x. To do that, I'll subtract 4 from both sides. It gives me negative 4 is equal to 2x. I have 2 times x. I want to undo that, so I will divide by 2. As a negative 4 divided by a positive 2, that gives me a negative 2. So my x-intercept is the point x equals negative 2 and y equals 0. I can come over here and graph that. X is negative 2, y is 0, is this point right here in orange. I also want the y-intercept. Now, since our line is in slope-intercept form, if we're comfortable, we will remember that this right here, the standalone constant, is the y-coordinate of the y-intercept. So I can just write down 0.04. Now, if we don't remember that, if we remember instead that this is the point where x equals 0, we can come to our line equation and put 0 in for x and solve. What do I have? I have 2 times 0, that's 0, plus 4. 0 plus 4 is simply 4. So in either case, I will find that when I put in x equals 0, 4. 4 is what falls out for y. Okay. Graph this, I get 0, 4. There's the point 0, 4. And then I simply need to connect those two to the best of my ability. Indicate that this line goes on forever. And I have it. All right, at this point, if you're asking why bother with all this graphic mess, then you are asking a valid question. It's always a good question. Why? Why am I doing this? Well, graphing is a useful visual tool. So if we've got an equation and we want to study how it behaves, graphing is very useful. Also for visualizing real world data. So when you go onto your science classes or your statistics classes and you're dealing with data, it can be really helpful to view a graph of that data. So maybe we can pick out some patterns that might be in there. Another thing that we can do with it is use it to solve equations. So if I have an equation here, I've got a little cheeky over here. Say I am given the equation 1/2 x plus 3 equals 5. We could solve this with algebra, and in fact it wouldn't be too taxing for some of us, which is fine. The other thing we can do is we can graph both sides of the equation and then look at where they intersect. And there are times when you're dealing with equations that are quite long and quite difficult to manipulate algebraically, where this is a completely valid way to view solutions. When I say graph both sides of the equation, I can graph, I'll just call it y1, the side that says 1/2 x plus 3, and I can graph the second side, call that y2, 5. y2 equals 5. We'll recognize y sub 2 equals 5. That's a horizontal line. I have drawn in the line y equals 5. I can label that. There. And I can put in the line 1/2 x plus 3. Go back to our recently discovered or rediscovered technique. We'll find the x and the y intercepts. The y-intercept we can read right from the equation. It is the point 0, 3. The x-intercept, we should do a little bit of solving. I give myself some space. Do it over here on the right. On the x-intercept, that's the point where y equals 0. Technically y sub 1. So we will plug in 0 in the y spot and then solve. Solve by first subtracting 3 from both sides. And to clear this 1/2, I can multiply by 2. Multiply everything by 2 gives me a -6 is equal to x. So I'm looking for the point -6, 0. There are my 2 points on the line, -6, 0, and 0, 3. Let me go ahead and draw in my line. All right, so plotting my 2 intercepts, there's one, there's the other. This gives me the line, call it y sub 1, 1/2 x plus 3. Now to figure out where the solution is, I'm going to look at where they intersect. This appears to be my intersection point. That seems to be the point that y is 4 and x is 4 and y is 5. What does that tell me? That tells me my solution is x equals 4. Let's confirm this by putting that into the equation. So if I do, I get 1/2 times 4 plus 3. That's 1/2 times 4 is 2. 2 plus 3 is 5, and that's what we wanted to see. So this does work. It's a completely valid way to solve equations. All right, let's try it again. This time let's try it on something just a little more complicated. This is our old friend from last time, 1/2 x plus 3. We've already graphed that. Let's see where it is equal to a -2x plus 8. Now, you should and can, of course, graph this again by hand. It's pretty straightforward, but let's see also how to do this using technology. I'm going to show you a graphing utility called Desmos, which you may have already used before. We'll use it again. I come over here, I go to desmos.com/calculator. This is always something very useful to use when you're studying or working on homework. I can graph both of these lines right here in Desmos very quickly. I have my input pane right here and my graph over here. I will just enter in these equations. Now I am going to name them. We're going to name them using function notation. I'll call 1/2 of x. I'll let that be my 1/2 x plus 3. I type in 1 divide 2. Now I'm stuck in the denominator of this fraction, so I can arrow over or click over to get out of there. Get my x in there, and then plus 3. There's my line. Click down or hit enter to get into another input panel. I'll call the next one g of x. That's my negative 2x plus 8. Negative 2x plus 8. I can zoom in, zoom out with the mouse and click. And it looks like my intersection is at the point x equals 2, y equals 4. Let's go ahead and write this down. I said x is 2 and y is 4. So at the point, and we're interested in just x at this point. So our solution appears to be x equals 2. We can confirm that by plugging it in. Let's go ahead and do that. I have 1/2 times 2 plus 3. But 1/2 times 2 is 1. 1 plus 3 is, of course, 4. We'll check the other equation. What's negative 2 times 2 plus 8? That becomes negative 4 plus 8. That is also 4. So yes, x equals 2 is the solution to this equation.